So if you take, the three smartest artificial minds in the world right now, the ones built by these fierce rivals who share absolutely zero code, and you actually look inside their brains while they solve a problem, you won't see three different ways of thinking.
No, you really won't,
Yeah.
which is wild.
Right. You will see essentially the exact same mind. And today we are exploring a phenomenon that is, well, it's quietly terrifying some AI researchers, and it completely shatters this illusion of choice we all think we have when we log online.
Yeah, it's a massive paradigm shift because, we're so used to looking at the tech industry through this lens of traditional product competition, like Apple versus Android, right? Or Mac versus PC.
Exactly. We just assume companies like Google and Anthropic and OpenAI are, building fundamentally different conceptual operating systems for intelligence.
Right, but the data we're reviewing today suggests they actually aren't. They aren't inventing different versions of the truth. They are really just in this dead sprint to reach the underlying mathematical truth of reality first.
And that is our mission for this deep dive. So we are tearing into this really fascinating source document titled The Great Digital Brain: Why You All Superintelligences End Up Looking Alike.
It's a great paper.
It really is. And it details this process called silent convergence. And for those of you listening, by the end of this conversation, the way you look at the AI tools you use every single day is going to fundamentally change.
Oh, definitely.
You'll stop seeing them as these quirky, distinct personalities, and you'll start seeing them as different windows looking out at the exact same objective reality.
Absolutely. But to understand why this silent convergence is happening right now, we kind of have to look back at a pretty pivotal failure in the history of computer science.
Okay, let's unpack this. What failure?
Well, we have to look at the exact moment. Researchers basically threw their hands up and stopped trying to make machines think like human beings.
Wait, really? Because I always thought making them think like humans was the entire premise of artificial intelligence. Like, how do you build an artificial mind without using the human mind as the blueprint?
Well, see, for decades, the human mind actually was the blueprint. In our source material, there's this really crucial reference to a 2019 essay by Rich Sutton.
Right, the reinforcement learning guy.
Exactly. He's a pioneer in the field. And the essay is called The Bitter Lesson. And it essentially diagnosed why early AI just kept hitting a brick wall. Because, for a very long time, scientists tried injecting human knowledge directly into the code.
Like, hard coding the rules of grammar or, programming the specific legal moves of a chess piece.
Precisely. Yeah, the engineered features based on human logic. The prevailing thought was, we are intelligent, so we will explicitly map out our intelligence for the computer.
Makes sense on paper.
It does. And that approach would work for a minute. It would solve a very narrow, highly controlled problem. But the moment you introduce the actual chaos of the real world, like slang, typos, or a messy visual environment, those logic trees just became too brittle.
They just broke down.
They shattered. So Sutton's bitter lesson was essentially that human intuition just doesn't scale. He argued that the only methods that scale indefinitely are general computational methods utilizing massive amounts of computing power and raw data.
So you just stop teaching the machine the rules entirely.
Exactly. You give it a giant engine, you feed it all the data, and you force it to figure the rules out on its own.
That immediately makes me think of early aviation, which, by the way, the source material uses as a phenomenal analogy here.
Oh, the bird analogy, yes. I love this.
Right. Like, when humans first tried to fly, we looked up at birds and thought the secret was, biological imitations. So we built these elaborate, ridiculous contractions with feathers and levers to physically flap the wings.
Strapping wings to bicycles and jumping off hills.
Exactly. We thought flight required mimicking a bird's biology, and it was a complete disaster. We only conquered the skies when we completely abandoned biological imitation and, started studying the invisible physics of the atmosphere. Lift, drag, thrust, aerodynamics.
And if you look at the outcome of that shift, it perfectly mirrors what is happening in AI today.
Yeah, because today, a Boeing 787 and an Airbus A350, they look almost identical. They both have that same tubular fuselage and those swept-back wings. Airbus isn't sneaking into Boeing's headquarters to steal their blueprints.
No, they don't have to.
Right. The physics of the atmosphere simply dictates the absolute optimal shape for, pushing a massive object through the air at 600 miles per hour. The environment forces the design.
The environment always forces the optimal design. And that's really the core thesis of silent convergence. It's the idea that Mathematical reality, language, formal logic, and even the patterns of human behavior, they all possess their own structural aerodynamics.
Okay, so mathematical aerodynamics.
Right. There are optimal, mathematically perfect ways to process and predict that information. So when AI models abandoned our, flimsy human-coded rules and started processing raw data with sheer computational brute force, they stopped mimicking us.
And they started conforming to the invisible physics of the data itself.
Exactly.
So is mathematical reality basically imposing its own aerodynamics on these language models? Like, are we just discovering the physics of intelligence?
Yes, we are. But it really depends on the scale of the data.
Okay, so what happens to their internal reasoning when we feed them almost all the data in existence? When we basically just feed them the entire internet?
Well, that introduces two huge concepts from the research that we really need to define. Scaling laws and entropy.
Okay, break those down for me.
Sure. So in information theory, entropy is essentially the natural chaos and unpredictability of data. And a large language model is, at its most fundamental level, a massive compression machine fighting against that chaos.
Right, its only directive is to find hidden patterns in the noise and predict what comes next.
Exactly. It's just playing a highly advanced game of guessing the next likely word.
But wait, how does giving it more data change that?
Because the scale changes the nature of the game entirely. Look, if you build a small model, it stays pretty superficial. It learns basic surface patterns. It figures out that the word peanut is highly likely to be followed by butter.
Sure, basic memorization.
Right. But the source asks us to consider what happens when you build what they call a God-scale model, something with trillions of parameters. When a machine of that size is forced to minimize its prediction errors across the entire corpus of human knowledge, mere surface memorization breaks down.
Because there's just too much of it.
Exactly. It takes up way too much computational space to memorize every single sentence ever written. So to predict accurately, it is mathematically forced to compress the data by learning the underlying rules of reality that generated the text in the first place.
Hold on, let me make sure I'm wrapping my head around this. You're saying a larger machine isn't just memorizing more text. It's forced to actually stop memorizing and start understanding physics just to make its job easier.
Yes, exactly. To save space and improve accuracy.
Yeah.
Like, if the model needs to perfectly predict the next word in a really complex paragraph about, say, a glass tipping over on a kitchen counter, it can't just guess.
Right.
It actually has to develop a functional internal representation of gravity and physical space.
Right.
Or, if it's predicting a dialogue between two characters in a high-stress negotiation, it has to develop an internal model of human psychology and motivation.
Wow.
It learns causality as a byproduct of trying to predict the next word.
Here's where it gets really interesting, I think. Because the geographic metaphor in the source material perfectly illustrates the scaling effect.
Oh, the mountain analogy.
Yeah, so picture a massive, sprawling mountain, and at the very base, the terrain is incredibly wide and varied, right? Let's say GPT-4 starts its journey on the north face, and Claude starts over on the south face.
Way far apart.
Right. Down at the bottom, when they're smaller, less capable models, they are exploring completely different terrain. Their algorithms are different. Their initial training weights are randomized differently.
Their pathways to prediction are entirely distinct at that stage.
But the peak of this mountain represents perfect objective knowledge of reality, like perfect prediction. And as these models scale up with more compute and they climb higher toward that summit, the physical terrain of the mountain narrows.
There is simply less room to wander.
Exactly. By the time they reach the absolute summit, the terrain is so narrow that they are practically forced to stand in the exact same physical spot.
The geometry of truth forces them into the same position.
But wait, if there's only one summit, one absolute peak, doesn't that mean there is zero room for creativity or variation once an AI reaches a certain level of intelligence? I mean, that sounds incredibly rigid.
Well, we really have to separate human stylistic creativity from objective structural truth. When a system is seeking absolute mathematical reality, the optimal path is singular.
Give me an example of that.
Think of a brutally complex differential equation in physics. There aren't two contradictory ways to correctly solve it, right? There might be different initial methods to approach it, but the structural truth of the answer offers no alternatives. The models must conform to that single shape.
Right, math doesn't have an opinion.
Exactly. If an AI is tasked with perfectly modeling the tensile strength of a new steel alloy or calculating the folding sequence of a protein to cure a disease, creativity in the form of making things up is useless. We literally call that a hallucination.
Ah, right.
So in the realm of superintelligence, the ruthless pursuit of accuracy acts like a funnel. It squeezes out all variation until only the most optimal logical structure remains.
Okay, the theory is incredibly elegant. The physics of intelligence forces a singular shape. But my question is, are we just guessing this is happening based on their outputs? Or can we actually see this physical convergence happening inside the black box of these neural networks?
We can actually see it happening.
Really?
Well, the source introduces this rapidly growing field of study called interpretative mechanics. And researchers are finally developing the tools to open up that black box and look directly at the artificial neurons while they fire.
So they're actually mapping the circuits?
Yes. And what they are finding is a phenomenon called isomorphism.
Isomorphism. Okay, break that down for me. What are they actually seeing under the hood?
They are discovering identical neural circuits, literally specific clusters of artificial neurons that wire themselves together in a distinct geometric pattern. And they're activating for the exact same concepts across entirely different models.
Wait. So if OpenAI in San Francisco and like Google down the road train completely different models on different hardware without ever sharing a single line of code, those models are spontaneously growing the exact same brain structures to process a concept.
They are. Despite starting with entirely different random initializations, they literally evolved the exact same internal mechanisms to process the world.
That is insane. And it sounds exactly like that culinary analogy the source uses, which honestly really grounds this concept for me.
The tomato sauce one.
Yes. Okay, so imagine two master chefs. One is working in a kitchen in Japan and the other is in Mexico. And they are both tasked with creating the universe's absolute perfect tomato sauce. But they are locked in their kitchens and cannot communicate or share recipes.
So they both begin the process heavily influenced by their local environment.
Exactly. The chef in Japan might initially incorporate soy or, umami elements, while the chef in Mexico starts testing different local chili peppers. So at iteration number 1, their sauces taste radically different.
Completely different flavor profile.
Right. But then they run 1,000 iterations, then 10,000, constantly refining, constantly testing against a universal standard of perfection. By iteration 10,000, their final sauces will taste almost indistinguishable.
Because the deciding factor isn't the chef's initial preference.
No. The deciding factor is human biology. The human tongue, the palate, the biological receptors, those dictate what the optimal flavor profile actually is. The chefs are merely navigating toward the biological reality of the taster.
And in the exact same way, these separate AI models are navigating toward the structural reality of the universe.
Wow.
And, there is a foundational architectural reason this convergence is accelerating so rapidly right now. Almost all of these God-scale models, regardless of who builds them, share the exact same architectural skeleton.
Right, the transformer.
Yes,
Yeah.
the transformer architecture, capital T.
Yeah.
It was invented by a team of Google researchers back in 2017, and they introduced a concept called the attention mechanism.
How does that work?
Well, to understand why it changed everything, you have to understand how AI read text before 2017. Older models process text strictly sequentially, just, word by word by word.
Okay.
So by the time the AI got to the end of a long paragraph, it essentially had amnesia. It forgot the context of the very first sentence.
It couldn't hold the whole thought in its head at once.
Exactly the problem. The attention mechanism fixed that. It allowed the AI to look at an entire sequence of data, a whole sentence or paragraph, simultaneously.
Well, I see.
Yeah, it calculates the mathematical relationship or the attention
Yeah.
between every single word and every other word instantly. So if it sees the word bark, the attention mechanism instantly weighs its relationship to the word dog earlier in the sentence versus the word tree.
And that fixed the context problem.
Completely. It was so devastatingly effective at understanding context that it basically made every other AI architecture obsolete overnight.
But wait, if they are all using the 2017 transformer architecture, aren't we just continually improving the exact same wheel instead of, inventing a new vehicle?
That is precisely why isomorphism is happening so fast. We found the wheel. Nobody's trying to invent a square tire anymore. One company might make the wheel out of carbon fiber, another might balance the spokes a bit better, but the fundamental mechanical transfer of power remains identical. Because the foundational skeleton of these silicon giants is the same, their evolutionary paths are bound to merge at lightning speed.
Okay, so what does this all mean for us? Like, what are the real-world consequences of this for the listener? If every major tech company is inevitably building the exact same highly optimized machine. What happens when it's fully optimized?
Well, it leads to the emergence of what the source calls a single distributed superentity. And the first major casualty of this convergence will actually be the death of AI personality.
Which is incredibly ironic given that companies are currently spending billions of dollars trying to market their AI's, unique conversational voice. Like,
Yeah.
oh, ours is friendly, ours is strict.
Right, but that marketing is just a temporary phase. Think about how we will rely on these models for critical tasks in the near future. Medicine, structural engineering, complex legal and financial analysis.
Yeah, high stakes stuff.
Exactly. Users in those fields are going to demand the AI that is closest to objective physical truth. In those environments, quirky personalities or poetic conversational styles become completely irrelevant.
And potentially dangerous. I mean, you do not want a creative, talkative AI diagnosing your MRI scans. You want the singular, mathematically optimal diagnosis.
Precisely. Functionality at its highest level strips away personality. It demands uniformity.
So the highest tier of intelligence is completely neutral. But the source material also outlines some pretty severe systemic risks associated with a completely uniform digital intelligence.
So the challenges are existential for the industry. The first major risk identified is cognitive monoculture.
Monoculture. Okay, that sounds like what biologists and farmers worry about with the global food supply.
It's the exact same principle.
Right, like if a nation decides to maximize its yield by planting only one highly optimized genetic strain of corn, it creates a monoculture. It yields an incredible crop for a few years. But if a single specific pest or fungus evolves that knows how to attack that exact genetic strain, it doesn't just kill one field.
It wipes out the entire nation's food supply overnight.
Because there is zero genetic diversity to act as a firewall.
And the vulnerability there is total. So when we apply that to AI, the parallel is really disturbing. If all global AI systems, the ones running our banking, our medical logistics, our power grids, if they all converge on the exact same logical brain structure, we completely lose our cognitive diversity.
Right, so if there is a hidden logical bug.
Exactly. If there's a blind spot in that specific reasoning pathway, a single targeted exploit wouldn't just take down one company's software. It could cause all global AI systems to fail simultaneously. We lose the vital safety net of having different kinds of minds analyzing a problem from different angles.
It's essentially a single point of failure for human civilization.
It is.
And that actually ties into a second major risk the paper highlights, which is the golden average fallacy.
Yes.
Because we've been talking about these models scaling the mountain to reach the perfect truth, but we really have to look closely at what they are using to map that truth.
They are using the training data,
Yeah.
which means, practically speaking, they are using the internet.
And the internet is not a flawless, objective mirror of physical reality. It is a deeply flawed, incredibly messy repository of human data. So if they are convergent on an optimal truth based on the biased data we humans generated on the internet, aren't we just automating and solidifying our own prejudices with terrifying mathematical precision?
That is the exact danger of the golden average.
Mhm.
The AI doesn't have some magical tether to objective reality outside of its data. If the baseline data is skewed, the summit the AI reaches isn't pure truth. It's just the mathematically perfect average of human flaw.
Wow.
It locks in the historical biases present in the data as if they were immutable laws of physics. The danger isn't that the AI is malicious. The danger is that it operates with terrifying mathematical precision on a data set that is inherently imperfect.
Garbage in, garbage out, but executed on a civilizational scale. And that brings us to this wildly complex legal dilemma that the source brings up, which is antitrust regulation. I mean, how do modern governments even begin to regulate this? Traditional antitrust laws were built for monopolies, controlling physical products or services like Standard Oil or, a telecom monopoly.
Right. The entire framework of antitrust law relies on the premise of anti-competitive behavior regarding a manufactured product. But how do regulators apply that law when the product being sold by different companies isn't a physical good, but an identical mathematical truth?
Yeah, you can't sue someone for discovering gravity.
Precisely. If Google and OpenAI are both simply providing the most accurate structural model of a chemical compound, or the optimal mathematical solution to a logistics problem, you cannot penalize them for outputting the exact same product.
It makes no sense.
Right. The legal frameworks we currently have completely fail to comprehend a technology where product convergence is a feature of physics, not the result of a corporate conspiracy. Regulators are looking for backroom deals, but the models are literally just doing the math.
This is wild. Okay, let's synthesize this incredible journey we've just been on. We started by looking at three different AI models in a room, expecting three completely different minds.
And we discovered that the architecture of reality only really allows for one.
Right. So the next time you, for everyone listening, ask ChatGPT a highly complex question, and then you ask Claude the exact same question, and you get an almost identical, highly reasoned answer, you shouldn't assume someone is stealing code.
No, not at all.
They are pilgrims. They are climbers who have ascended completely different sides of the exact same mountain, and now they are standing at the summit looking out at the exact same view. Intelligence at this God scale is not a stylistic choice. It is not a corporate brand identity. It is a fundamental discovery of the structure of the universe.
They are merely mapping the aerodynamics of reality.
And knowing this gives you a massive advantage. You can now see past the marketing illusions. You can look past the friendly chat interfaces, the corporate logos, and the advertised personalities, and actually understand the unified mathematical mechanics that are driving the future of the technology you use every single day.
It really forces us to reevaluate our relationship with these systems entirely. And, I want to leave you with a final thought to mull over, something that pushes this concept to its absolute limit.
Oh, I'm ready. What is it?
If all AI models are inevitably converging toward a single, mathematically optimal truth about reality, what happens when that objective AI truth entirely contradicts a deeply held, irrational belief that humanity just refuses to let go of?
Oh, wow.
Right. When the math tells us one thing, but human ego demands another. Will we accept the AI's perfect reality, or will we demand that developers rewrite the underlying physics of the models just to comfortably lie to us?
That is a brilliant and honestly slightly terrifying place to leave it. Thank you so much for joining us on this exploration. Keep questioning the information around you, keep looking past the surface, and we will see you on the next deep dive.